Hello guys, welcome back to another episode. Today's episode we are going to solve this Geek for Geeks daily challenge where we have to find common nodes between two BSTs. So basically the problem is given two binary search trees, find nodes that are common in both of them. So we have to find common nodes. So we have one, this is the first BST and this is the second BST, and we have to find the common nodes like where here we have 4, 7, then 9 and 10. So 1 2 3, what they are looking for is I think they're looking in sorted orders. Return common node in sorted, yeah, so they are expecting in sorted order. So how to do that? What I'm thinking is let's create two array. So let's have array 1. I'm just okay, I'll just write code logic here. So we'll have two array, one array for each BST, and then here are 2, and then what we're going to do is we're going to we're going to find another array that is intersect of these two, that is arr 1 and actually it is like list of set of arr1 and set of arr2. Then what we're going to do is we're going to do just sort, and what we're going to do is we're going to, so this is find intersect, then this is to sort, and then we're going to return our intersect. Now the issue is how we're going to get the traverse. So how we're going to traverse it. So to do recursive traversing, what I'm thinking is to just do another function. Let's have def function of, say, let's traverse it in order. So as usual we have class, so we will do that, and then let's have a root. Now here we have to return one array because it will be like, so we have to go and accumulate each and every one. So for each individual level we will have to accumulate all of them. So let's do it, and if no root is none, what we have to do is we have to just return empty array, so then it will not do anything in front. Otherwise arr equal to arr plus, again we have to call in. Okay, so I'm just writing it here, but it should not be here. So as we are sorting, we are doing it in order, and so just to remove confusion, what I'm doing is arr dot append root data. So we are adding current root, and then we're traversing to left and right. This is just to remove confusion. I'm going to move it to this. So self dot in order, and then we're going to pass root dot left. Same thing again, copy, paste. Now what I'm going to do is we're going to copy it, paste it here, and change this to right. At the end, what we're going to do is we're going to return return arr. So this is done. So our logic, what it will do, start from the root node. It will go to the left. So basically it will start from here, it will go to left, then again it will go to left, then it is not finding anything, so it is going to return empty array. and then it will in next step it is going to append your data into this array. Then it will go back to this place as and then add again the data. Then it will check for right. Now it is having right, so it will again go for left. It will not find anything. Then it will append this one and go to right, and it will not find anything. So again it will go back to 5 and append it, and then again same thing will happen to the right side thing. So that is why it is called as in order. So left first, then middle, and then right. Now in order to drive this entire thing, what we have to do is we have to call this function for both of our BSTs. So what we are going to do is we are going to call self dot our function this guy in order, and we are going to pass root 1. Then again we are going to copy the same thing, and we're going to call for root 2. So this is how we're going to solve it. Let's try. uh, Typo. Oh, let's try now. Yeah, let's submit it. And it worked. Okay, then see you tomorrow. Thank you.